you can see my screen. Can you hear me clearly?
Yep.
So for those who are first time with us, yes, we're serverless user group, but we started like normal backend function service developers. But over the years, we became started defining serverless as a new agile serverless mindset because it helps us deliver products faster, and we mesh really well with product managers. So our focus has shifted from pure technology into reducing the gap between business needs and IT, because very often we are like car mechanics who enjoy pimping our cars, but the car sits in the garage instead of us driving the business forward. So we are trying to help companies accelerate, and these are the ways we are doing it through a couple of approaches. One is like meetups like this, where we introduce new serverless services or managed services. So you have new blocks in your toolkit. For instance, if you didn't know yellow block existed, you wouldn't be able to use it in your next architecture. We also like bringing more business-focused topics. So we had a couple talks about healthcare and life sciences. There was a recently talk about smart cities and IoT, which brings new perspective both to you and the organizations. And also we are offering, like beside networking and us like community, we are offering free second opinions on application and data architecture to help businesses move forward. But if that's not enough, a number of us are here consultants, so we offer for free consulting services regardless how short or long they are. And to get started, like you can fill in the survey, I'll paste the link in the chat, and then we connect you with the gurus from any cloud like you plan to work or you're using currently. And I hope this is not the first and the last time with us that you're going to come again to upcoming meetups. We already have 3 meetups scheduled. In December, you're like in for a treat. Like Felipe Hoffa spent a long time with Google. He was a guru in BigQuery. Now he's developer advocate for Snowflake. So he's going to explain to you Snowflake and how he adopted it coming from the Google cloud. You're in for a treat because I think that currently in the market, 2 best cloud data warehouses are BigQuery and Snowflake, and we're going to learn from the best. Our group has started when Amazon Lambda, AWS Lambda was announced, and so we pretty much after every reInvent have a recap of most important serverless announcements. However, when COVID started, these announcements became recorded and they were the same. So this time we're going to do something different. James Beswick is senior developer advocate from Amazon. He's going to come in January to present not only most important events or announcements from the conference, but also kind of to inspire those who haven't adopted serverless technologies to start playing, because he runs a number of workshops and tutorials. So he's preparing something special for you. In February, also, is going to be amazing meetup, very practical. So number of our events are inspired by the things we see at work. That's why they're all over the place. So on one of my recent projects, I was working on BigQuery, and we were using a Looker BI tool. That's an amazing tool with Looker ML modeling language that now they are open sourcing it right now. And in the process, I met Leah Jarrett, who used to be a developer advocate for Looker, but now she's a developer advocate for Google BigQuery and BigQuery ML. So you are in for a treat because she's going to present both technologies and give you a third data point, a practical example to apply both technologies into retail analytics. So that's going to be February meetup. And then after that, we are open, like feel free to suggest presenters or volunteer to talk, as long as it's not pitching something that's helping the world be a better place. So we open to have you on our stage here. And then please rate us so more folks like you can find us and visit us here. And last but not the least, our sponsor for years now has been Manning Publishing. At the end of every meetup, we have a raffle, and they're giving any product for free. In order to participate in the raffle, you have to do the survey to tell us how to be better, and then Manning and us will give you a product of your choice. And now, thank you, Jarek and Brian, for visiting. We are blessed and lucky to have you with us. Please take it away and teach us about Vertex AI. I'll stop sharing.
Yeah, thanks, Daniel, and thank you guys for hosting us. Logistically, Brian will share his screen, and since he will be doing a lot of deep dives, so he will switch slides for me. So Brian, if you can share your screen. So the topic for today, we were asked to deep dive a little bit into a Google Cloud ML platform called Vertex AI. This is a follow-up to the session our colleague delivered a few weeks ago when he talked about some ML initiatives and assets in Google Cloud. And as a follow-up to this meeting, we're asked to deep dive a little bit into the Vertex AI. So the way we're going to do that, to kind of spare you from too many slides, I will spend maybe 10-15 minutes to do an overview of what Vertex AI is and how it is positioned in the context of a broader machine learning engineering lifecycle. And then Brian will do a lot of deep dives into specific features of the product. And we are more than happy to answer any questions. We can answer them as we go if you raise your hand in the Meet, yes, and post the question into the chat, or we can allocate some time towards the end to answer the questions in more detail. So thanks again. My name is Jarek Kazmierczak. I'm with Google Cloud Solutions Engineering. My main focus is on ML engineering tooling and large-scale ML use cases, accelerators, including both GPUs and TPUs. I'm based of Google Quantum Computing Research Center in Santa Barbara, California. And I'm joined by my colleague, Brian, who is an enterprise customer engineer focused on AI ML portfolio for Google Cloud. And Brian is based in Boston. So let's start. Brian, can you? So what is Vertex AI? Yeah, this is kind of a marketing definition of the product. Vertex AI is Google Cloud's unified development and deployment platform for data science and machine learning. And I emphasize unified development and deployment because these are the nouns which very well describe the primary positioning of the product. And I will kind of deep dive a little bit to each of them as we go through the product. It is unified because as no, if that's okay, you can switch. It is unified because, as you will see a little bit later, it unifies a number of previous efforts we had in an ML space. It is development and deployment. These are the keywords. Yes, it is focused on the full machine learning lifecycle. A lot of tooling in the space, which historically has been rather fragmented, tends to focus on one area, even kind of the deployment phase after the models were developed, or a development experimentation phase. What we attempted to do with Vertex AI is to cover the full end-to-end life cycle of a machine learning system. And this diagram summarizes how we view this life cycle. If you are really bored, yes, you can read the white paper which we wrote, which is over 40 pages, which dives into a nitty-gritty detail of this life cycle. But on a summary, this diagram shows major phases or processes which are involved when building a production-ready industrial-grade machine learning system. So let me quickly summarize them and then kind of map to key technical capabilities which we thought are important if you build the system to support this life cycle. So machine learning, as you know, is very much a research activity. Developing a machine learning system, developing and training machine learning models involves a lot of experimentation, a lot of development, a lot of iterative development. So this phase called ML development is really important. And in many cases, in many processes, this is kind of the main and the only phase of a machine learning lifecycle. In many situations, when you develop a one-off model, or the model which will not have to be retrained on a regular basis, the outcome of an experimentation may go to deployment directly. Or in many cases, unfortunately still in real life, the outcome of experimentation ends up on a shelf. Yes, so this is one of the, again, issues we try to address to make sure that outcome of research, outcome of experimentation process are deployable, and eventually they make it to production. So outside of those fringe cases, from our perspective, in most machine learning systems, the models will have to be retrained on a regular basis. So the model development doesn't stop at experimentation. After we settle on a machine learning model architecture, after we settle on a core features which will be used to train machine learning model, we quite often move to the phase which we call continuous training phase, where we retrain the model on new data on a regular basis. And in some extreme cases, and a good example of that would be recommendation systems, you may have to retrain a set of models which comprise a recommendation system at least daily, in many cases multiple times a day, yes, which is a pretty significant endeavor. That's why in our machine learning lifecycle, we specifically emphasize this phase called training operationalization, which is how do we take all the IP and artifacts developed in experimentation and refactor it to production level code, which can be run on a regular basis and produce candidate models. Yeah? So this transition from experimentation to continuous training has been historically an Achilles heel of many machine learning system and many machine learning tooling. Okay, so continuous training phase will produce models, will produce model candidates, and through the process which Brian will deep dive a little bit further, yes, of evaluation, a specific model candidate is selected, and then it goes through the deployment phase. And again, yes, in many of the traditional tooling, this deployment phase was relatively neglected, and it is a complicated phase of a life cycle, since models can be deployed into many different runtime environments. The same model can be deployed as a cloud service, it can be deployed on an embedded device, it can be deployed in some on-premise infrastructure, it can be deployed for online serving, it can be deployed for batch serving, it can be deployed for offline but near real-time serving. So there's many deployment scenarios, and in many situations, this deployment of a model also means integration of a model and model artifacts with some other external systems. You deploy a recommendation system, it is usually deployed in the context of a website or an online system, which puts very high performance requirements, let's say for latency and for throughput. Yeah? So having good tooling which manages the deployment process and packaging of the model artifacts into deployable package is very important. And then we, of course, have a serving phase of serving the model. Again, yes, in addition to the focusing on efficacy of the model from kind of non-performance metrics perspective, there is a huge also a huge emphasis on making sure that the predictions generated by the models remain at certain levels of performance, required levels of performance. Yes? So you have this phase of continuous monitoring, when you monitor the model as it serves predictions to detect phenomena like model decay or data shifts and concept shifts. There's a whole large body of science around monitoring models after they were deployed. All of those processes would not be possible if not for the central, very important process of managing data and model artifacts throughout a life cycle. And you will see that from tooling perspective in Vertex AI, this emphasis of managing data artifacts, managing model artifacts, managing model metadata is very important, because this is the glue which binds everything together, and this is the glue which allows you to implement this end-to-end life cycle in a unified way. Can we move to another slide? So now this is just a different version of this diagram with the focus on those data and model artifacts which are generated through the life cycle. And so assuming that eventually you will retrain the model on a regular basis, one of the primary outputs of an experimentation development phase is a set of code and code configurations which implement training pipelines. Yeah? So those artifacts are then assembled into runtime artifacts by this training operationalization process. So, for example, yes, your training code is packaged into a component which can execute now in a repeatable training pipeline. Or the code which validates, profiles the data and validates the data for correctness or for data evolution, the data shift, is also packaged as components. And all of those are eventually deployed as a training pipeline and associated training pipeline components into the runtime environment, production environment, in which you repeat executing this continuous training pipeline. The outcome of this pipeline, as I mentioned, is a set of model artifacts, which on this diagram referred to as a registered model. Registered means then, in addition of creating those artifacts, like a trained model, like some pre-processing and post-processing routines, we also register a lot of metadata about this model, how it was created, the lineage of the model, which can allow you to trace back to the datasets which were used to train the model, some information about the model, which will make it much more streamlined to deploy the model in a specific deployment scenario. And then the outcome of this model deployment process is some form of a serving package. It can be a container. It can be something which is embedded onto an embedded device. It may be not only the model, but associated code around the model, which does pre-processing, does post-processing, does monitoring, and so on. And so there's always this component of CI/CD related to packaging the model artifacts into something which can execute efficiently in a specific serving runtime. And as we serve a model, we generate, collect serving logs, which are instrumental in monitoring for model decay, for those phenomena I described before, data set shifts and drifts, which may indicate that the model does not perform as well as it did when we started to serve predictions from a model, and it's time to even retrain the model, or maybe even in extreme cases, re-architect the model, come up with a new model architecture, because the environment we are trying to model change so much that the current model architecture doesn't meet expectations anymore. And again, yes, for all of that to be possible, for all this process to be implemented smoothly, we need a very robust system for managing data, metadata, model artifacts, model metadata. Brian, can you move on? So to be able to do that, we need a platform, and this platform needs a set of technical capabilities. So this diagram kind of abstracts and synthesizes typical technical capabilities you would expect from a machine learning platform, AI platform, which is designed to support this end-to-end lifecycle. And we will very much focus on going deep into specific capabilities when Brian does his deep dives, but kind of on a higher level, obviously, and I probably emphasize it too many times, but this is so important, the foundation of the platform is very strong metadata and artifact management, which extends, again, into both model and data. And then there is a set of services you would find related to supporting experimentation. So even development environment, which uses one of the standard widely adopted tooling for ML development, like Jupyter or Jupyter Lab environment, or arbitrary IDEs, or systems to track experiments, to track results of experiments, to compare multiple experiments you conduct during development phase. There's obviously a strong set of services the platform should even provide or integrate with services which can do data pre-processing at scale. And machine learning is, in fact, a lot about data pre-processing, a lot about data management, a lot about data transformation to transform the source data into the formats required by a specific model architecture. Obviously, model training, yes, you need services which will allow you to train models at scale, to support distributed training, to support training on accelerators, GPUs, TPUs, or other forms of accelerators. You need very strong capabilities to do model evaluation, to know when to stop training, but also to be able to compare the models, to select the model which will get deployed. You need a very high-performing serving platform, which will allow you to serve models using one of those paradigms I described before: online, offline, embedded, at large scale, at high throughput. You need online experimentation capabilities, which allow you to properly test the model in production before it is widely deployed. Yes? So these are usually capabilities which allow you to do the progressive delivery of a model. Yes? So to do your green-blue deployments, to do your canary deployments, to perform A/B testing of the models, to perform MAB testing of the models. There's quite a lot of sophisticated tooling which is required to do that. And of course, you need to be able to monitor the model after deployment, and you need to be able to orchestrate all of it, and again, register and track model and model artifacts. Next slide. So this is how we deliver those capabilities in Vertex AI. Yes, and I'm not going to drill down to every feature at this point, because we'll do it later, yes, as we do demos of specific services. But I also want to go back to this unified keyword, which I used before. One of the features of Vertex AI is that it unified a number of ML assets, a number of ML services we had before, which tend to be not very well integrated. So for example, yes, Google Cloud for a long time has a set of technologies referred to as AutoML, which provide a streamlined the workflow for developing machine learning models, where some of the typical tasks you perform when developing machine learning model, like feature selection, model selection, model hypertuning, were automated in a unified and very easy to use pipeline. This system was not very well integrated with the tooling for custom model development, where you perform those steps in an ML workflow through custom code components. So in Vertex AI, we integrate those two sets of services into a unified system where you can kind of mix and match, and you can utilize the same tooling, the same API, the same infrastructure to implement the workflow, which is more fine-tuned to your specific model development scenario. And this is where unified, the keyword, comes into. Then I also mentioned development and deployment. Yes, so you will see a lot of services which are focused on this development phase and which are focused on deployment phase. Again, I'm not going to get into all of them, but let's focus on kind of a key ones. Notebooks, or as it is right now called, Workbench. This is a core component of a platform which provides a development and experimentation environment for data scientists. It is a managed solution which allows you to configure very powerful virtual workstations, if I'm going to use this term, which can be optimized from both hardware and software stack perspective for a specific time of development you want to do. So for example, you can provision yourself an instance which will feature tens of CPUs, hundreds of terabytes of RAM, and multiple high-end GPUs as your experimentation environment. Yes, and you can provision it, you can run your experiments, and then you can stop it and deprovision it. So you don't have to upfront make a huge capital investment required to build this experimentation environment. It also can be configured with multiple software stacks. So the same workstation can be used concurrently to develop multiple models, to switch between the projects, and maintain very strict configuration management for a software stack. So let's say if one component of your solution is developed in TensorFlow, and the other one is developed in NVIDIA recommendation system framework called Merlin, and you can have environments optimized for this type of development and maintain, again, very strict configuration management. And if there are any Python developers in the audience, you've experienced probably pain of dealing with configuration management for Python. Yes, so this solution allows you to take control of that. Another key component of Vertex AI is a training service, which allows you to run large-scale, small-scale, medium-scale training jobs with virtually any machine learning framework, including frameworks which support distributed training on tens or potentially hundreds of nodes, including support for utilization of the latest and greatest GPUs from NVIDIA, including support for Google proprietary machine learning hardware called tensor processing units or TPUs. I think we lost, okay, for a moment here. And with support for automated model selection, with support for very sophisticated hyperparameter tuning here. So very powerful, very critical service in Vertex AI. Vertex AI Prediction, a set of services which help you with deployment and serving of the models, again, supporting online scenarios, batch scenarios, supporting high scalability, serving through GPUs, serving through CPU farms, and serving in effectively using any of the model serving technologies which have been widely adopted by the industry. And the Vertex Prediction service can also be augmented with additional services like explainable AI, which help you with interpretation of the predictions made while in production, and services like continuous monitoring, which help you with detecting model decay, dataset shifts, dataset drifts, and other anomalies which can happen to data while serving models in production. Pipelines, Vertex Pipelines. This is a very key component which allows you to implement those workflows I described. And I think that Brian will spend quite a lot of time on pipelines to show you Vertex Pipelines, which is a ML optimized workflow engine. By ML optimized, I mean it has certain capabilities which make it much more streamlined and much more optimized for orchestrating machine learning workflows than other generic workflows engine, which sometimes are used in the machine learning context. Other services like Feature Store, which help you manage enterprise features for machine learning in a unified, high-performance way, and of course, ML metadata. Yes, on this diagram, this is a very small service, but I probably sound like a broken record by now. This is such a critical service to be able to build this unified platform, which allows you to automate and operationalize those end-to-end workflows. Next slide. You can combine those services in many different ways. This is just one possible way you can combine Vertex services to implement kind of end-to-end development. So you can see that your experimentation and development environment is done in Vertex AI Workbench. The code and configs which are generated as part of this experimentation process can be stored in any version control systems. It can be GitHub, it can be code repository, which is Google Cloud specific service. Then those code components and configs will be operationalized and run through a CI/CD pipeline to build runtime components, which can be deployed as a continuous training pipeline. Again, you can use any CI/CD system. We will integrate with anything, but you can also use a native CI/CD system in Google Cloud called Cloud Build. Those continuous training pipelines would generate new model versions, new model candidates, will register those models in a model repository, or relatively in some future, a new service called model registry. And everything is tracked through ML metadata. Yeah? So this whole end-to-end pipeline can be implemented by assembling individual services of Vertex AI. One way of thinking about them maybe as Lego blocks, yes, which are so flexible and well integrated that you can adopt your pipelines to your specific use case. So I think that I tired you by now with slides. So let's do some deep dives. Let's look at demos. Let's look at the code samples. And again, if you have any questions, we're more than happy to answer them as we go, or do it later after the deep dives.
Thanks, Jarek. So I do have a couple more slides. Sorry about that. Jarek got you all excited about a live demo, but we'll get there. So I want to start with, just before I get into kind of the demo flow, talking about, I think there are a number of different MLOps platforms out there, including Vertex AI. And, as the audience member, you may be wondering, like, what's the difference? Like, what do people like about Vertex versus some of the others out there? So I just wanted to kind of share that before I went into it. Jarek mentioned this, but the first thing is really Workbench. Workbench is our managed notebooks, as you mentioned. We have two versions right now. One is fully managed. So basically, you do nothing. You click on it to start it. It starts and you use it. And then there's another one called user managed, which is a VM gets spun up. So there's a little bit of potential management there. The difference is the fully managed version is just in preview. We haven't made it generally available yet. It's available to use, but they're still working out the kinks. Whereas the user managed notebook is fully GA, and you can use it right now. It comes with pre-built libraries like TensorFlow, PyTorch, scikit-learn, straight up Python. A lot of the different frameworks that are typically used. A Kaggle version for the typical libraries that are used in Kaggle competitions that may be of interest to some of you. So Workbench is very popular. And then moving from that, services are very similar. So you might work in other tools where if you try to do training or serving or try to build a pipeline, it may kind of work differently. But in Vertex, things are all kind of the same. We have templates that we've published on GitHub that are for training, for prediction, for pipeline. They all kind of look the same. And it's because they kind of use the same general steps, which I'll show in a little bit. So that makes it easier to use. We've got a lot of support for containers. And so if you're familiar with coding containers and building things using that, you'll be very familiar. We have YAML and JSON inputs and outputs, which is typical for a lot of different software products. And then the ability to use accelerators is across the board, GPUs and TPUs, as Jarek mentioned. And then from there, we've got an SDK that is something you can use to work with Vertex. And the basic gist of it is you can pretty much code everything you need to do. And if that's something that you like, some customers like the GUI and the UI, and that's available as well. But a lot of our customers, and Googlers, especially, love the SDK. Scalability, it's been touched on. We have really big network that's whenever you use a service, it's on our network. It connects to each other very quickly. We have the ability to scale our CPUs as well as our GPUs and TPUs. So we just have a lot of scalability there. And then in terms of integrations, once you get data in cloud storage or Bigquery, it's fairly easy to use from our various different services in Vertex AI, just to make it simple. And this is kind of what the demo is going to go through. Don't know if I'll make it through the whole thing. I'll do my best. But basically, the gist is I'm going to walk you through Workbench just to show you kind of what that looks like, what the benefits of the fully managed version is there. And then I'm going to try to take you on a little journey. I'm going to take you on a journey of a team that has some models they've built locally, and they now want to kind of like take it to the next step. And maybe they start doing some distributed training, maybe some hyperparameter tuning, and then they're like, oh, okay, my model is good. Like, what should I do next? Like, I want to make this automated. So they may look into Vertex Pipelines and take that process and automate the process of training and deploying the model. And then from there, I'll touch on CI/CD for continuous training. A colleague of mine built a pretty good GitHub repository to kind of walk you through that, and I'll share that link as well. And then I'll touch on model monitoring, which is basically looking at how the model is performing, There's an example notebook that I'll briefly show you that basically asks for a bunch of predictions that are very different in terms of the distribution compared to how the model is trained. So the model is trained on a bunch of different countries. The predictions are coming from one country, and so that issue occurs where, hey, the distribution of the training is much different, and that gets triggered. So I'll show that as well. All right, so let's go into the Workbench. All right, so the first thing about the Workbench I wanted to show is they're trying to bring as much as they can into this notebook environment so that you don't have to leave the notebook environment to get what you need. So as example, like here's Google Cloud Storage. This is the list of different folders within your bucket. And if you wanted to, you could look at the files to see which ones you want to use for training. You could also upload files as well if you needed to, and just trying to make that simple. So that's Google Cloud Storage. The other one that's kind of cool is Bigquery, which is similar, but as the database. And let's say, you were looking for data sets and you kind of want to see, hey, what's in this table? What's it look like? They've set it up so you can just kind of right click on the table name and get the description of the table here. And here you got both like the table info in terms of the size and the rows and when it was created and everything like that. The ID.
Brian, can you increase the font size? There was a
oh yeah, of course.
question on the chat.
Yeah, no problem. How's that?
Good.
All right, great. So basically, I was just saying there's the detail about the tables. And then, hey, I want to kind of like look to see what the data looks like. You have the ability to do a query directly from a notebook and see the data itself. And then once you're happy with this data, nice thing about notebooks is you can basically say, hey, I want to now use this data for my test model. And here you're just using the Bigquery magic command to put the data from that same query that I just showed into a data frame and putting it into there for your use for training. And this is kind of just a sample of the data. All right, so that's just Bigquery and storage, some of the things there. The other thing is, let's say you've got long-running code or like a local training that is taking a long time here in your notebook, and you want to kind of like have it go, and when it's done, you can just come back and see the results of it. There's this thing called an executor, and basically it will execute the commands in your notebook and use the hardware that you specify. And you would need to select basically, if this is just Python, so I would select Python. But if it was like a TensorFlow training job or something like that, you can select TensorFlow. Or if you needed to, you could add a custom container if these didn't work for you. And then you would execute it. And what happens is you get this result that gets dumped into your storage bucket after the job is done with the execution results. So basically, rather than sit there and wait while this takes forever or maybe never completes, you have this run via the executor. It executes the code and provides the result, which is this in this case. And you can also schedule that. So basically, when I did executor, this is a one-time execution, but you could also do a schedule-based recurring execution if it's something that you want to run on a regular basis. So that's kind of like the key things in the managed version that we have available today. Actually, one last thing, Jarek mentioned this. So you can modify the hardware as well versus just like executing the job. You can also just change it to have heftier hardware. So here, like, let me just pick a ridiculous one. Pick a 96 CPU, 768 gigabyte RAM machine, or you can just stick to the one that you have and attach some GPUs. Let's say I want 8 V100s. So once you do that, it would take about, maybe 5 to 10 minutes to reconfigure behind the scenes. But after that, you would have this available to run your notebooks against. All right, so moving on, let's go to So as you can see, I switched from managed notebooks to user managed notebooks. And the main reason is because I like to use Docker for containerizing my code. And right now, our managed service doesn't have support for Docker. So that's why I'm here. But let's go to that scenario that I mentioned before, where you've got a data scientist. They are working locally. In this case, they built a model to classify pictures of products on their website. In this case, this is fashion MNIST data. But let's say it's like different types of products, and they want to be able to classify them into 10 different categories. So, they have a local model that uses TensorFlow. They have a couple of arguments that it takes in. They take in the number of epochs for the training. They take in the number of neurons for the second to last layer in the neural net, which I guess I'll touch on a little bit. There's some pre-processing to resize the image.
Someone is requesting to increase the font size.
Yeah, sorry about that. I'll do that. Is that better?
Yeah, that's good.
Great. All right, and then the data is being pulled from TensorFlow datasets, so not much there to really speak on, other than it's just pulling and then shuffling and batching the data. And then this is the layer I talked about for the model. Basically, it's just determining the number of neurons for the second to last dense layer, and then compiling it. So pretty straightforward. And then, basically the main function is getting the arguments, getting the data, creating the model, and fitting it. And that's about it. And then I have a step to basically train it locally here. And, it may take some time, but eventually it finishes up. So, so like this happens a lot. There's like a lot of experimentation, a lot of iterations of this, but hey, if they're like happy with this version and they're thinking, okay, I want to train it now against a larger data set, and I want to, use like more hardware that maybe we don't have available to us, can we leverage a service like Vertex AI? Then the next step would be going into distributed training. And the way, what I mentioned earlier is we have similar steps for most of our services that we have in Vertex. And I just wanted to walk through what the template does. So the template basically, first of all, installs any packages that you might need. So let's say you use the straight Python environment, so no other libraries, and you'd have to install TensorFlow and a bunch of other stuff. But in this case, I have a TensorFlow environment, so all I really need is Google Cloud Platform or Google Cloud AI Platform, so I can do some of the other things that are that come with the Vertex AI SDK. And then whenever you install any new libraries, you would restart the kernel and wait for a little bit, and set up your project. And timestamp is nice if you are wanting to make sure if you're running the same job a bunch of times and you want to kind of be able to delineate the differences or the different runs that you had. So that's why that's in there. And then if you're using our user managed or managed notebooks, you don't need to do this step. There's no need to authenticate. Then you would either create a storage bucket or you would use an existing one. And then from there, you would import your libraries and do your various things that you need to do, and clean up at the end of that. So that's the kind of general template. So let's go ahead and go into distributed training. So from here, we have, let's see, already went through most of this stuff. So I'm going to kind of go down. So this is a local training code again, basically from before. Nothing's changed. So from there, if we want to go into distributed training, there's a couple things that you might want to add. And so they might think like, hey, when I train locally, I can kind of see the progress locally. But what about when I'm in the cloud, or what about when I'm in Vertex AI? How do I see how the runs are going? And so you may create a Tensorboard, and this is a managed Tensorboard that you create within Vertex AI. And here we've given the name called Custom Training Tensorboard, and we'll use it later when we do the training. And here we're either setting a specific service account you want to use for your jobs, or your if you set it to nothing or you leave it as default, it'll get the default service account that it's using. And here I just left it as default. All right, and then before I move on here, I'll just show you what Tensorboard looks like. I mean, if you've used this before, it looks very similar, but this is just our managed Tensorboard that's in Vertex. And in this case, we've got a couple things it's looking at: epoch accuracy as well as epoch loss. And over the course of training, the training accuracy did better than the validation accuracy. So there may be some issues with the model that we need to look at. It looks like it might be, it might need to be tweaked. The layers may need to be tweaked a little bit, or there may need to be some dropout layers. Okay, so the steps of creating a model, and in this case, I did a training container primarily because we do have pre-built containers that you can leverage. But if your library that you're using isn't a part of that pre-built container, then you have to move to custom containers, and a lot of our customers end up doing that. And so it's something that I wanted to show. And here I just created a local directory to store all my files for the container. Created a Docker file that is from a TensorFlow image, but adds a custom library that I wanted to add to this. And actually didn't need to use a custom container for this because Cloud Hypertune is in this image, but I just did it as an example. And then here I have the local training that's been adjusted a little bit to work in Vertex. And a couple of things I did was I set some variables for where the model is going to be stored, where the checkpoints and the Tensorboard logs are going to be saved. And those are defined up front. I defined what do I want my hyperparameter tuning metric to be. And here I'm looking at accuracy or validation accuracy. The args function stays the same. Process data and create data set is the same. Create models the same. I added this function called HP tune callback, which is a callback to store all the metrics for the hyperparameter tuning process. And I think it stores every epoch at the end of each epoch. And let's see what changed here. I think I added a checkpoint callback. That's basically to save the checkpoints as the training goes. So if the training were to be stopped by the user or something, they would still have the best checkpoint available. And then I added the Tensorboard to this code as well, so that it would write to the Tensorboard here. And then within the model.fit, I added the callbacks so that those, basically the checkpointing, the hyperparameter tuning callback, and the Tensorboard writing would happen. And then finally, I think this was in the local code too, but I did a model.save to the model directory within Vertex AI. All right, so we've got our training code defined. We've got our, let's see, what else did we do? We've got our Docker file, and now we're just gonna go ahead and create the container. These aren't that important. You're just creating an artifact registry if you don't have one, doing some commands to allow Docker to run, setting the name of the repository as well as the training image. And then from there, we're going into that trainer directory, which has the Docker file and the task.py file, and building that image and then pushing it to the artifact registry. And then from here, initializing some of the SDK libraries I need and importing there, initializing it using AI platform.init. And then what you'll notice, this is the case for both training and deployment, is you'll define what type of accelerator, if any, that you want, and the number of accelerators you want. And then you'll define the type of machine you want for your training and deployment. And here I'm just doing training, so I kind of commented out the deployment ones. And then since it's TensorFlow, you do need to set the TensorFlow or the training strategy. So since I'm using a GPU, the strategy is going to be mirror, which will allow to leverage the GPU. And then I'm setting the args for the model training. And with all that, I kind of find it, there's a lot of steps to that, but what you end up with is this thing called a worker pool spec, which is defining the machine type, the accelerator, the arguments, the training image. That was the reason for all those prior steps. And this goes into the training call. All right, so now I'll just call the custom training job, or define it by creating this thing called job, giving it a name, and passing in that worker pool specs that I just mentioned. And here I'll just go ahead and run the job based on those settings. So that's kind of like how they would take their local training into a distributed training process. And then for hyperparameter tuning, what they would do is add a couple of additional things. For example, they would import hyperparameter tuning from this library. They would define what is the metric that they want to measure in the tuning job, and then what are the parameters. And in my case, all of my args, both the number of epochs and the number of neurons, are the things that I want the hyperparameter tuning job to kind of figure out what the best, best option is for those two things. And then similarly to the distributed training job, basically taking using the library AI platform and calling hyperparameter tuning job. The primary difference is it takes in that metric spec, parameter spec, the max trials and parallel trials as parameters. And then it takes in the job from the training job, which is up here, as an input. And then you just do a job.run, similar to the way the other thing worked. And when you do that, this is kind of what you get in the UI. Basically, it's a black box tuning process. It's going to go through the different parameters. In my case, I said number of epochs between 3 and 15. And then I gave it like a set of 3 or 4 different number of neuron settings to try. And based on that limited set, determined that 15 epochs and 128 neurons were the best combination. All right, so that's distributed training. There's a lot more here, obviously. You know, we use GPUs, but you could have used bigger distributed CPUs, could have used TPUs. That's kind of the flexibility you have here. But now let's say you've got your model, you've got your tuned parameters, you're pretty happy with it, and you know you want to like put it into a process so that it's continuously trained or automated actually, so that all the steps that you just had in this notebook are done for you regularly on a either scheduled or a regular basis. And in that case, you may move to pipelines. And with pipelines, we've already built the training code. We've already built the logic for the pre-processing, all that stuff from before. What we then need to do is define a couple of things similar to what we did for the training. In this case, we're defining the deployment GPUs as well, because in this pipeline, I'm not only going to train it, but I'm going to do a couple other things. So let me actually show you what the pipeline is going to look like, so you get a sense. All right, can everyone see that okay? Is that big enough?
Yeah,
Yes.
for me.
Great.
Yes.
So in our distributed training, we did one step, which was basically custom container training, right? And it outputted a model with a certain set of accuracy. Oh, actually, we did 2 steps. We also did the hyperparameter tuning step. But in this case, hey, we want to like take this model. We want the pipeline to train it. We want it to then check the validation accuracy to see if it's worth deploying. And if it is, then I wanted to create the model endpoint and deploy it there, right? So here we've got the training, it outputs a model. And from that, there's some metrics from the model around accuracy, validation accuracy loss, and things like that. And I have this operation to basically say, if this model is greater than, has a validation accuracy that's greater than 0.85, I want it to deploy it. I'm sorry, I can't make this any bigger, I don't think. But that says 0.85. And some of the other things is it tells me like where the various things from this pipeline are stored. You'll get a lot of good information here when you click on these different operations. Let me go through this first. So it's going to check to see if it's better than 0.85. And if it is, then it's going to go to this next condition and basically say, yes, it is greater. And this will trigger if the condition is true. So once the condition has been found to be true, it will create a model endpoint. It will then, once that's completed, go to the next step of deploying this trained model to that endpoint. What I did want to show is just some of the stuff that you can see here. If you look at, let's look at the training one. If you look at it, you will see a summary of kind of like when it was run names. And then if you go to pipeline proto, which is kind of hard to see, you'll get more of the detail of all the things that this job was configured in the ways that it was configured. Then if you go to the node info, you can go directly to the logs by clicking this button. And you can also go right to the job if you want to see the run details itself. And you also see like what were the arguments that were passed in, and it was a project, other things like that. And then this is the output. This will show you where it is in Vertex AI. And if you go to lineage, it will show the full process of kind of how these different objects were created, which can be pretty useful. All right, so this is the custom container training job run, the artifacts created from that. And then here's the model. It just basically shows you the steps. There's not much to, I've already kind of walked through this. So here's that evaluation of whether the model is good enough or not. And here's the deploy decision and the deployment. Yeah, and it even tells you like what accelerators are being used by each of those. So let's see this one. This one doesn't say. Yeah. All right, so going back to the notebooks. So we're kind of going backwards, but that's the full pipeline. And what was done to get there was we first defined what were the accelerators for both the training and the deployment that we wanted to use. Machine types, which is similar to kind of what happened in training. We defined the worker pool specs again. And then one difference is we defined some additional libraries. There's KFP, which is the Kubeflow Pipelines library. Google Cloud Pipeline Components, which is the core library for this. There's a couple of others Kubeflow pipeline that come from Kubeflow pipelines that are used specifically in the pipeline itself. We define a pipeline route for the objects that the pipeline generates. Got a base output directory as well. This was in the last, we already had the metrics thresholds, I'll skip that. And then the way those steps that you saw in the pipeline work is via component. So here we've got a component that is called the class if model evaluation metrics, and that's the one that checks to see if the model is good enough. And there's inputs and outputs for that. That basically look at the value of the metric and determine whether to return a true or false. True means yes, it's better, let's deploy it. False means it's not. And so that was the only custom component I had to build. It's custom because I had to write the code myself, right, using Python. But a lot of components are just built in. So here we've got a custom container training job run up, which is like the distributed training custom job that we did before, but it's within a pipeline. There are some additional things that you need to pass in, but it works very similarly. So this basically creates that training up that's in the pipeline. And then we've got this custom operation that I created that takes in the threshold and the model from this operation and determines whether we should deploy it or not. And here there's a deployment condition that only happens if the decision is true. Otherwise, it just skips it. And in that case, it will create the endpoint using a pre-existing operation that we have, as well as it'll do the model deployment as well. And all of these kind of work similarly as well. And then in terms of how the pipeline is executed, there's a compiler that compiles this into a YAML file, or is it a JSON? It might be a JSON file. It's a JSON file. And then from there, you define a job similar to what we did with the training pipeline or training job, and then you run it. And that creates that job that we saw before. All right, so that's not a quick process, just so you know. It doesn't happen in a few days, but let's just assume that this team of data scientists has now gotten this pipeline and they've built it and it's looking good, but they're thinking, hey, I want this to be triggered based on a GitHub repository that I have where we're submitting code, either our pipeline code or our model code or whatever. And once we commit that to a particular branch, say called master or production or whatever, I want that to kick off a training run for this pipeline. So if that's the next step, adding CI/CD to this process, one option is similar to what Jarek was showing before, is to have something similar to this, where you've got a source repository like Git, or our source repository, and you're updating code, pushing it there, and once it hits a particular branch, what you can do is set up a trigger within Cloud Build that, and it could be any other tool that does this, but basically you can trigger a build so that commit to that branch causes both the pipeline and any of the underlying training images or deployment images to be recompiled, and after that execute the pipeline again so that the model is retrained, and you have a new deployment of your model. So I'm not going to go into too much specifics here, but I'll link this GitHub repository to you. My colleague developed this just recently, and I'll walk you through the whole process of how this would work within Vertex AI. Basically has a notebook environment that you can use to set this up, and it'll walk you through the steps of setting up a branch within GitHub or some Git repository, setting up the trigger in Cloud Build, and then having that trigger the recompile and the build of the pipelines. All right, so now let's say you've got your CI/CD integrated, you've got your pipelines, everything's running great, but you notice some of the models are starting to get stale, or some users are complaining about some of the predictions they're getting, or something along those lines. One of the things you could then add is model monitoring, and this is just an example of a customer churn model that basically has model monitoring enabled. And some of the thresholds that were set were basically, if anything goes above 0.01, let me see if I can make this bigger. Yeah. If anything goes above 0.01 in terms of training serving skew for this particular feature, then I wanted to send me an alert. And currently it's an email alert that you get. And here's one that's interesting. And the only reason it's interesting is because I think I mentioned earlier, but basically the example notebook that we have sends a ton of prediction requests from Japan. And this model is trained on a number of different countries. And so that's why this one gets triggered. But if I click into there, you'll also see what the distribution is expecting and what the distribution is in predictions. And as you can see, it's actually not that, doesn't look that different, but the scale is the problem. The scale of the chart is an issue. Let me show you the other one that looks a little bit more clear. So this is the expected distribution, and this is what the training distribution was. And so if you set up the monitoring to the certain threshold and you get changes of distribution between your prediction and your training, then these alerts will kick off. Yeah, I think that was it. I guess to summarize, if I go back to the slides, the transition between like local model development to distributed training is probably one of the rougher ones, because you're having to figure out both like how to templatize your code, how to containerize your code, how to monitor it, with Tensorboard in a managed service and things like that. So that could be a little bit of a jump. But once you get there, you then, not doing a lot more to add it to a pipeline and get that into an automated process. CI/CD is a whole other discipline as well, but actually integrating pipelines and Vertex to a CI/CD process is not complicated. And then model monitoring can be enabled for most of our models when you deploy them, and so that's a pretty seamless transition too. So I guess like my goal for tonight was to hopefully not overwhelm you, but to kind of give you a gist of what a team or an individual going from like their own modeling on their own notebook, in their own laptop, etc., how that might look transition-wise, and hopefully I did that okay and answered some questions for you.
Amazing. Thank you so much.
Sure.
I did not expect this practical hands-on sessions. Thank you. So guys, now we can go through the questions. There were some in the chat. So Jarek, you want to read it? Or Brian, you can.
Yeah. Do we want to? Do you know where the first question starts?
I think it was Q before pipelines. After the thumbs up, everything else was answered, I think.
Oh, okay, great. Okay. So yes. So Vertex Pipelines supports Kubeflow pipelines and TensorFlow Extended TFX. I think based on our documentation, Jarek, correct me if I'm wrong, Kubeflow pipelines is the preferred method. TFX adds some nice components that you can leverage if you're using TensorFlow.
So yeah, Kubeflow pipelines is a more generic framework because it can be used with effectively any machine learning framework underneath. TFX is still very much a TensorFlow optimized framework. You can use it, or you can use some of the components with other frameworks, but as of today, it is very much TensorFlow optimized component system. Now, TFX is an opinionated framework, meaning that it has an opinion about specific steps which should comprise a machine learning pipeline. And if your scenario fits the TFX opinion, then you can develop those machine learning workflows relatively quickly. However, it is not as generic and not as flexible as Kubeflow pipelines. So yeah, it's kind of your choice. Yes, in many cases, Kubeflow pipelines will give you more flexibility, but will require a little bit more development. Yeah, and yeah, I would if Sherry kind of made a statement, is it a preferred framework for TensorFlow? In most cases, you will find it very well optimized for TensorFlow development. Now, TFX is also very optimized for tabular data. You can use it to implement workflows with the other data modalities, but a lot of components are very optimized for tabular data.
Yeah, that's right. And I would also add, like, one of the reasons why teams use TFX is they need the scale. Their data is super large. They need to have access to Apache Beam or Dataflow. That's another reason. Let's see. So the next question was, in the whole process of the last hour, what are the roles people play? Typical titles, who does what? Is a developer doing most of the DevOps, ML specialist to do this? Okay, so it varies somewhat widely. But I would say the biggest distinction is probably between who develops the training pipelines versus who deploys the models. And sometimes those can be separate. It might be like an ML engineer or a DevOps person deploying the model versus like data scientists and ML engineers building the training models and the pipelines for that. And then let's see. CI/CD, I have a less handle on that, but I think that's probably a combination of DevOps and ML engineers from what I've seen.
Just to add to what Brian said, this is very cultural. Yes, as Peter Drucker once said, that culture eats strategy for breakfast. There will be organizations like Google on a lot of teams, which have a very integrated teams with no clear definition of roles. And there will be organizations when you have very distinct roles of a data scientist, ML engineer, DevOps engineer, and so on. Yes, so from tooling perspective, we don't enforce any specific team structure. We provide a set of services, but we also do provide some knobs and levers in the tooling. But if you do want to have a demarcation point and let's say access control boundaries between different roles, you can implement them in Vertex AI, but we don't necessarily enforce any specific team structure.
Right.
And Marcio had a question about GitHub repo. For the code.
Yeah, which GitHub repo, the CI/CD one or the Vertex AI samples?
I think it was a Vertex AI sample. Something was not. Somebody shared the link above.
Yeah. Do you want us to, Daniel, do you want us to send links after this, or should I just put them in the chat?
Either way, I will reshare every link that's here in
Okay.
the chat. So whatever's easy for you.
I'll do both. Here's Vertex AI samples. And
Brian,
here's the CI/CD.
Was that distributed training notebook inside Vertex AI samples?
I'll find it for you.
Perfect. Thanks, man. Appreciate that.
Yeah, no problem.
Yeah, great presentation, by the way.
Thank you. I see a question about other languages in Python like R. So we do have an R notebook within our managed notebooks, yeah. But it's not like
Sorry, go ahead, Brian.
I was just gonna say it's not like RStudio. So it's gonna be different, but there is an R version. Go ahead, Jarek.
Yeah, so we do support R kernel in Workbench. Now, most hardcore R developers will use RStudio. They will not use Jupyter kernels. We do not have a managed RStudio solution. We have one available through Google Cloud Marketplace, which is provided by RStudio, but this is a paid for offering. Now, also, this is my biased opinion, but R is an amazing language for a lot of exploratory modeling exercises. It is a rather challenging framework for deployment and operationalization. Yeah, so this would be a longer discussion, yes, but it definitely has some more challenges than Python-based frameworks. So there was a question about Bigquery ML versus Vertex AI versus AutoML. So somebody obviously knows Google Cloud well. Yeah, it would. How many hours do we have left till the morning?
As long as you want. Like my wife is not here. My kid is in UK.
It's a very complex topic. However, so I won't answer the question because the answer is I spent 14 years in consulting, and there's always one good answer, which is it depends. But The bottom line is that there are integration points between Vertex AI in Bigquery ML. So Bigquery ML is an equal citizen in a Vertex AI ecosystem. So if your scenario calls for the modeling and deployment scenario, which are aligned with Bigquery ML, on a high level, meaning your data is already in Bigquery, one of the supported models is implemented by Bigquery ML, and you most likely will do serving and predictions on data in Bigquery in a batch mode. Yeah, then Bigquery ML is a good choice, and you can use Vertex AI, let's say, development environment and some other components to help you with Bigquery ML development, or you can track Bigquery ML models using Vertex AI metadata, and there are some more integrations coming. Same. We kind of answer Kubeflow pipelines versus TFX question before. Now, AutoML, I alluded to that in my presentation. AutoML now is an integrated part of Vertex AI. This is yet another way of training. The AutoML provides you automated feature selection, automated model selection, and hyperparameter tuning. So usually, like a very high-level guideline is, if you can solve a problem with AutoML, solve a problem with AutoML, because it's very easy and fast. If you cannot solve a problem with AutoML, because as any auto system, it is more constrained, then you kind of revert back to custom model development. But I would highly encourage anybody to very quickly try to solve the problem with AutoML. And in 70–80% of cases of relatively mainstream scenarios, you will be able to solve it with AutoML.
Yeah, and I was gonna just add to that. I had planned to do this, but didn't have the time. You can run BigQuery ML and AutoML training jobs from within pipelines. So one of my thoughts of a good pipeline to show was to do a parallel training of BQML, AutoML, and a custom model, and to take the best model and deploy that. So those are things that you can also do within pipelines. So I did a custom model because that's kind of like I think the most complicated and the thing that requires the most explanation. But I could have replaced my custom model with a BQML or an AutoML just as easily. And those have built-in operators in pipelines that I could have used.
That's cool. Guys, you don't need to type your questions in the chat. You can speak up. We have another half an hour if you want to stay. Feel free to turn on the cameras.
There's another question about typical things for training data. So the two canonical ones are Google Cloud Storage and BigQuery, because this is where most of the analytical data, which is used in downstream ML pipelines, resides. And as such, we have kind of native integrations between Vertex AI training, R in GCS and BQ. Now, the emerging storage and management mechanism, especially for tabular data, is Feature Store. We didn't deep dive into Feature Store because it's a broad topic, but Feature Store is a managed service which we envision will become more and more important in managing training tabular data and also managing serving tabular data. Nothing really prevents you from developing custom code. The devil lives in detail is for accessing data in some other data sources in your training code. However, the most common pattern would be to have a data ingestion step, which would retrieve data from kind of a source system, whether it's a relational database or some LOB application, then push those extracts into even BigQuery and GCS, and then kind of run additional pre-processing steps. As you know, ML pre-processing can be quite complex. There will be, in many cases, a data engineering pipeline somewhere upstream, and then there will be additional steps which do pre-processing specific to ML. Things like vocabulary buildings, data normalization, conversion, encoding of data. Those are steps which are very specific to ML. and they are usually done downstream from a source systems like GCS and Bigquery. The key decision when selecting a storage subsystem for a large-scale machine learning training, especially distributed training, is performance of a storage system, especially when streaming the data and reading. So that's why solutions like GCS and BQ are usually used, because they provide you those capabilities. But in many training scenarios, you can also piggyback on storage subsystems used in high-performance computing, so like distributed NFS or other file systems used in HPC. But I would say the two which you mentioned, GCS and BQ, are kind of canonical and most frequently used ones.
Don't be shy. This is like a meetup. Turn on the mics and let's engage.
So feature store, is feature store GA? I'm on vacation, yeah, so I don't know.
It is GA.
It's supposed to go GA sometime.
It's GA, yeah.
Okay, cool. So it went GA when I was surfing. Yeah.
I think David Mitchell had a question around kind of like the team structure and best practices. I sent you a link there. That's pretty much the best we have, I think, on our site. Happy to kind of like talk more about it, but there's nothing like we have that says, here's the teams that should be doing X, Y, and Z. If that makes sense.
Yeah, thanks, Brian. It's more a question of, you've normally got a whole team of people who have to be on board with the process.
Yep.
And the demo is great, but I'm trying to think, okay, so if I have to bring, another 4 or 5 people in, and we all have to work together effectively, how does it actually work? But I'll follow that link. Thank you.
Yeah, I think just to get a sense for how to transition what I did on the demo, if you can get the whole team to kind of buy into the whole process of how that worked. So if you have, like, for example, there's a bunch of customers out there who have data scientists who use their own libraries, their own machines, and write a bunch of code. And then once they're ready, they hand it over to the ML engineer, and the ML engineer is like, how do I build this? Like, how am I supposed to build this? And it takes months to basically get it working, right? So if you can get them on the page of, oh, can you at least containerize your code? Can you at least like use our existing like library or like images that we've defined as the the golden images to use? Can we do that? Like, and if you need new libraries, can you use installs within like whatever the things that I showed that can be like agreed upon across the different groups, the better like situation you'll be in, because then every step of code shift will be that much easier.
Yeah, thank you. I appreciate that. I'll go through and I'll share the presentation around too. Thank you.
Sure.
But this is interesting point you bring, Brian. So that means really you need 2 roles: one data scientist who figures out the best algorithms, and like he's like making the engine of the car, and then the chassis builder to put the engine in the car to be on the road. So you need 2 main roles: ML engineer.
Yeah, there's more than that, but simplifying it. And the other thing is, like, the data scientists often do kind of like shift a little bit over to the ML engineer role too. There's a lot of smart data scientists out there who can do that as well, and they do. So
So the one of the kind of ideas and visions going forward, building ML pipelines, doing CI/CD, to some extent, those are commodity activities, which hopefully with time will be automated with good tooling. Yes, definitely as an industry, we are not there yet. That's why in many cases, you do have dedicated roles to developing machine learning pipelines, deploying the models, because tooling is still not perfect. Yes? But as the tooling matures, some of those actions can be performed by data scientists. So like if you can, I don't know, let's say sometime in future, there will be a GUI designer which allows you to drag and drop standard pipeline components onto the pipeline, or pick like a templated pipeline and modify it a little bit. This will be simple enough that it may not require a dedicated role to do that. But definitely as an industry, and I'm not referring to Google, but to the industry in general, we are not there yet. Yeah? Same as with CI/CD. It's getting better and better, but definitely it is still quite involving activity. Although, again, I would say that compared to other stages of the machine learning workflow, those are kind of commodity tasks which we want to commoditize, yes, as much as possible.
Yeah, thank you.
Any other questions? We still have 20 minutes and Raffle.
So there was the question about other data modalities but tabular, which whether to use TFX or KFP. Again, yes, it is one of those. It depends. You can use TFX and TFX components to implement pipelines which process both imaging and NLP data. There are some components in a TFX framework which are optimized for tabular data, and they don't have good equivalents, like data validation components or schema generation components. There's something called semantic data validation for those data types in TFX, but it's not as mature and sophisticated as tabular data. But other components which coordinate model training, model evaluation, there's nothing unique to tabular data. So you can use TFX to implement those pipelines. Same goes for KFP. It would, again, probably be more dependent what framework do you use for a specific workflow. If it's TensorFlow, the TFX could be used quite effectively for imaging and NLP data. We do have samples from both on the TFX side. Now, assuming, of course, the image data set is TF record format I'm quoting, it is convenient, but it is not required. TF record is a common format used with TensorFlow, but again, there's no hardcore dependency on TF record format with TensorFlow. You can use other data formats. It all kind of depends on a scenario. But yeah, you can use TFX with TensorFlow or KFP with other frameworks. Okay, what do we have?
Feel free to chat, guys. This is like a meetup now.
Yeah.
Presentation is over.
Yeah, we don't have to limit the discussion to Vertex AI. Yes, any ML topics which go beyond Vertex AI, we're happy to comment or answer to.
I think there was a question around AutoML and what goes on under the hood. So was that Tomo? Okay, so I'll just respond. So there's a couple of things right now. There's like it's a little painful, but you have to go in the logs and look for the model log, and it'll tell you kind of like the type of model and some of the information about what was used in training. So that's one option today. There's more in the works. They haven't released basically when it's going to happen, but there's more in the works. That's pretty much all I can say about that.
And it also depends on a type of AutoML. Like AutoML is not a single unified technology. The different types of AutoML for vision, NLP, and tabular will use a little bit different underlying backends. So for AutoML tables, there is quite a lot of information logged, as Brian mentioned, in log files. You will AutoML table models are ensemble models. So you will see in the logs which models were tried, which hyperparameters were tuned, and what's the final ensemble model for tabular. There's some information for vision. There's very little information for NLP, surprise, surprise, because AutoML NLP uses a lot of proprietary technologies from Google, yes, which are complex and high value, yes, so we don't necessarily publish everything what's happening underneath auto ML natural language processing. But yeah, we are trying to make it as transparent as possible and easier to reuse going forward. But to be like fully transparent as of today, I assume that the context for this question is taking the AutoML model and fine-tuning them later manually. This is not a fully supported scenario. So. Yeah, quite often it is XGBoost, true.
Yeah, like penicillin, 80% of problems solved with XGBoost.
I've seen deep neural nets in there. Come on, Paul.
This is an ongoing discussion and argument between classical machine learning algorithms and the DL school. If you talk to, let's say, somebody like Geoff Hinton from University of Toronto, he will claim that there's no point of wasting your time studying anything else but deep neural networks. But
So wait. Paul doesn't cut his baguettes with the chainsaw. That's surprising.
Can you repeat
if a
that?
chainsaw is
It's the only way to
inexpensive
cut
and
a baguette.
efficient, why not?
Can you repeat about what Hinton said? There is no.
Well, I don't want to quote him, yes, but definitely he's in a camp that pretty much anything can be solved with neural networks,
Mhm.
and he has, I guess enough esteem and track record to prove it.
Mhm.
Now, yeah, this is a little bit of a light and joking discussion, but you
Mhm.
definitely see that deep neural networks are entering domains which before were successfully solved with our algorithms, and there was no need for DL algorithms. A good example are recommendation systems. Yeah, I spent a lot of time with recommendation systems, and for a long time, there were all kinds of relatively simple techniques used in recommendation systems which work well. And in the last few years, there is just an explosion of deep learning algorithms in recommendation systems. And all the big guys who use recommendation systems, Twitters, Amazons, Google, Snapchats, all the modern systems are heavily utilizing deep learning algorithms. So there is a commoditization and a wider acceptance of deep learning algorithms in a tabular data space, yes, which is relatively new.
Cool.
So the question about, again, TFX and KFP. I don't think there is a competition between TFX and KFP. It's true that both frameworks originated in Google and in two different Google groups. TFX is a framework which originated in a TensorFlow team, which is Google proper, Google Research, and KFP is a development which originated in Google Cloud. If you kind of track the evolution of those frameworks, about 2 years ago, there is a strong attempt to unify them into a single framework. There was a bunch of RFCs submitted to open source communities to unify them. That never happened, and I don't want to go into the details why. Yes, there's a lot of good technical reasoning behind it. So the current thinking is that the frameworks will kind of develop relatively independently. And that's why in Vertex Pipelines, we made a decision to support both of them equally. Yes, and it's really now up to you to choose which one better fits your scenario. And again, yes, if your primary development environment is TensorFlow, TFX will be very attractive. If you have to deal with massive volumes of tabular data, some of the TFX components have been highly tested with massive volumes of data, so they can be used effectively. And KFP, being a little bit lower level framework, will give you much more flexibility. And it's not as opinionated as TFX framework. Now, if you don't agree with standard steps which TFX proposes, then KFP will be a better choice. Yeah? Like there's whatever number of components in TFX, and they have a very opinionated view of how machine learning pipeline should look. Yes, so there is an ingestion step, then there is a data schema generation step, data validation step, training step, model evaluation step, and then deployment step. Yes, so these are kind of the steps which TFX, I wouldn't call enforces, yes, but this is the standard flow.
Cool, folks. I only see 11 people put their names for survey for the mining title. So go again and do that. There was at one point almost 50 people on the call. And it's a free product. Anything you want, book, video, course, any topic. Here's the link again. So any more questions?
I'm just curious about the point a couple of people made. I see this competition between frameworks as a positive thing. You've got lots of very smart people with strongly held opinions, and it's a battle of ideas. Either the great ones will win out, or there'll be some sort of meeting in the middle. But yeah, this is the way we make progress.
No, I totally agree, especially that we are talking about frameworks which are developed for open source efforts. Yeah? So it's not like Google controls them. Yeah? This is an open source effort where we may be leading a working group, but there are contributions from wide, many participants in the industry and also individuals. So they kind of, by design, evolve naturally, yes, and they will be, if there is strong community support for a specific framework, it will continue to evolve and be used, and if there isn't, it will be obsoleted and it will die natural death, like it happens with a lot of open source initiatives.
Yeah, I have many friends telling me that I need to start learning Julia, but Python works okay for me to this point. At some point, it might not. At some point, I might need to learn Julia, but let's just wait for that time to come.
Oh, yeah, but this is in fact excellent example. I'm a huge fan of Julia as a language. It's a really nice language and very well suited for HPC and computational scenarios. But so far, it hasn't gained acceptance from a broader community. Maybe time will come. It is in fact very interesting because one of the reasons for Python having a little bit of a tough time in couple of years ago or so was performance. But with now all the efforts driven to some extent by Microsoft to improve the performance of Python, it may be this may go away as an issue of Python. Yeah? So now you have a widely accepted language with the best ecosystem definitely for scientific computing and machine learning, and the performance issues and bottlenecks may be removed. So it may have a much longer time span than people anticipated a few years ago.
Paul had a question. Paul, you want to say it? Like, you don't need to type. If you can turn on the mic.
Do you have some resources? Yeah. Oh, we have a lot of, maybe as a follow-up, we'll send you pointers to reference guides and articles and blogs, which are available on Google Cloud. Now, pretty much every cloud vendor, yes, will have a lot of good assets around benefits of using the cloud in ML scenarios, not only Google Cloud, but yeah, I would highly encourage to kind of scan both Amazon, Microsoft, and Google Cloud for those assets. But from our side, we'll definitely follow up with some links.
What does DS stand for, Paul? Getting DS.
I assume it's data science.
Data science. Okay. Okay. And
yeah, our language. I remember about 5 years ago, there was this huge discussion, R versus Python, stats being published. And since then, we know that Python definitely gained more acceptance. Now, R is still very broadly used in a specific set of scenarios. So if you have like background in life sciences, yeah, or social studies, or more mainstream statistics, this is still a teaching language, and this is still a widely used language for publishing assets in that space. But when it comes to building production-grade machine learning systems, where the model is deployed in the context of an application rather than publishing a results of a data science study, definitely Python has been, Python won this competition.
And maybe I didn't understand fully Paul's question originally. So I think if he watches the meetup that Luck had 2 months ago with you, that will be good enough motivation for your data scientists to explain move to the cloud. Luck's point was that it's more important to have high volumes of data, break out the silos, than the particular algorithm. So make sure to give that talk. I said it here to your team to watch. That's kind of introduction to this course.
Yeah, I would also add, some of my customers have found that if you can give them something that they lack, like whether it's accelerators or access to data, that can be a good driver for change.
I'm just afraid because MLOps and DevOps are so similar. Based on the questions I heard, I've seen in the real world, when DevOps started, it was supposed to be a line between development and operations. In many organizations, it became a wall. Not in Google, you came up with SRE. But like now that DevOps guys are moving to MLOps, there is a risk it becomes bureaucratic. So these roles and stuff and kind of pragmatism, if you can help, like what you did with SRE, something like.
Definitely, there's no point of reinventing the wheel. A lot of processes, a lot of tooling in MLOps is and should be and should leverage all the experiences with DevOps. Like at the end, it is all about operationalizing the building of software components and then kind of helping with managing deployments. There are some unique aspects of MLOps, mostly related to managing data. Yeah, this is what's unique about machine learning, that it is really heavily dependent on proper data set and feature management, which when you kind of look back at software engineering practices, there was a relative division or separation between kind of data engineering processes and pipelines and software engineering processes and pipelines, and MLOps kind of brings it together. But no, at the end, you have to, at some point, build your components. You have to version control, manage them. You have to progressively deliver the artifacts you created. So all of those experiences from DevOps are fully applicable to MLOps domain.
Cool. And I want to be cognizant of everyone's time. I can stay longer if you can stay. Let's just do the raffle quickly to see who's going to win the book. So this is the last chance. Go to that link. I can share the screen and let's see who's going to win anything from Manning. So this is fully transparent. You can see.
Then you're going to get the names from the survey, right?
Yeah, so the name, so yes, I do have names. So I'm going to, no, that was today. And then we're going to go to Wheels of Name. I think this was the program. Can you see my screen?
Yep.
Okay. Anybody? You're double. No double dipping. Okay. So
they sorted out. It's good.
Jarek. And then
my name is there for 2 times.
Who?
I thought to.
Sorry, I cannot.
What? Vivo are you?
I cannot hear you.
My name is available for 2 times. So.
But what is your name? I cannot see.
Voroganti?
V. Yeah. This name. But where is second time? Down. I see. Okay. Anybody else who did not do survey? I can put your names here.
I'm staying out, Daniel. I won twice. Remember?
That's okay. Like I feel bad last time I told you cannot win again. So let's see if you're going to be winning third time.
Can I get your lotto numbers?
Sure, put me up then for Harold Hoyts.
So Harold.
Yeah.
Oops.
That's
Anybody else spinning? Okay. Good luck. You have to be here. Ta-da! I don't want to risk and butcher your name. Are you with us?
Satyaram once.
Satya.
Are you here?
Yeah,
If
yes.
you're here. So put your email address in the chat, and then we're going to connect later. Go to manning.com, choose anything from them, and please ping me because I tend to forget if you don't ping me. So today I had to give 2 prizes because people didn't reach out to me in time. So I'm stopping the presentation, and now we can resume with the questions if there are any.
Did you get his email?
Nope.
Okay.
Can you put the email in the chat? It's recorded. I'll find him, but it's better to have the email. Perfect.
Yeah.
Perfect. Okay.
Yeah, this is Sachin. Hi, Jarek and Brian. A great presentation and discussion. Yeah, something I'm interested in is the model monitoring aspect. And I wanted to ask you, where do you store metrics like feature distributions, and is it available even at the serving time? Might be interested in the feature distributions on live requests, right? So is that a thing?
Yeah, so the model monitoring service allows you to, this is one type of statistics which is stored. They are stored in a protocol buffer format. Underneath, the system uses a TensorFlow data validation library. So this information is accessible, and it is accessible through the higher level API. But if you the underlying implementation is what I described.
Yeah, and Sachin, just to touch on the available at prediction time point, if you don't have a training distribution, it can also look at the skew of your prediction data and alert you if that goes beyond what you want it to be. So yeah, that's available as well.
Yeah, so one is called, this is kind of loose nomenclature, but the shift and drift. Yeah, so if you do have access to training data distributions, then you can detect the shifts. And then if you don't have access to training data distributions, you can monitor drifts in the serving data. So then you kind of calculate those statistics, including feature distribution over a specific time window, and then this can be used to compare against newer data.
Oh, yeah, very interesting. Thanks.
Any other questions, or are we going to go back to our families? So see, people are leaving. So if you can send me the link to the presentation slide deck and any other resources you want us to share with the folks, I will edit the video within a week probably and put it on YouTube playlist where other videos are. So it's youtube.serverlesstoronto.org. That's a redirect. And much appreciated for you being here. I hope to see you again, and I look forward to learning more from you. So.
Thank you, guys.
Thank you so much, Jarek and Brian.
Thanks for the presentation.
No problem. Thanks everyone for joining us late time.
No, thank you for doing this. This is amazing.
Thank you, guys. Appreciate it. Have a good night.
Bye-bye.